Hi everybody, I'm back again here. Okay, so what we got here, it's GPS and we have an LCD screen running. The chip is ESP8266 and it's a mini probe VMOS. Okay, so what is this one is showing is tracking the International Space Station. Is giving us the altitude and the speed, which is altitude is about 438 kilometers above the Earth, and the speed is about 27,500 kilometers per hour. Then it shows a latitude, which is 40.69, and the longitude, and it shows the distance from me now. It's 5,600 kilometers away. Okay, so what else we got here? Okay, this is, you can check here on the website that track the space station. In this case, there are several ones. I've just picked this one because it's working. And the NASA and the international NASA and the European at the moment is not working. So I just picked up this from Astro ISS viewer. Okay, so here's the 38.40, and which is 38.40 and 87, and if you look at here, it's about correct. And the timestamp as well is 38.03, 87 and you can see. Okay, so it is tracking correctly. So, and it's in kilometer. Okay, so I can back again and you can see. I could make one next to each other. I'm not so sure how to do that. Okay, so, and this is the distance from my coordinate, which calculated with a formula. It will be able to tell me that I'm 6,300 kilometers now away from the International Space Station, ISS. Okay, now these are the codes, which I will put them on the YouTube channel, and you can see you're going to need quite a few library. Tiny GPS++, this one works with your GPS. Software serial, because we're not using TX and RX. We're using TX and RX from the GPS, but on the chip we're using pin number 3 and 4, which need a serial to initialize the pins. Okay, liquid crystal I2C is for the LCD 1602. It's called 1602 because it's got two row, okay, 2 row of 16 block each row, so it's 32 block, so it's 16 and 16. Okay, it's 16 2. There you are. It's 2 row of 16 block each. Okay, so back to the code. Okay, so we got all this website. We got Arduino JSON, which is for it's for parsing. Okay, so when your data gets updated every few seconds, it needs to be parsed. Then you have we have all the other library. You just have to download it from this point here. Okay, so you type it here and it will come up down there. All right. Then I've got secrets, which has got my username and password, so I can't publish it here. And it has my what do you call it? My API key. But here you put your API key, not my one. And this is the ISS ID, which is 25544. in this case. But if you want to use this program, you can put other satellite ID that you want to track, and then you can change some of the name here on your screen, but you will still have your latitude and all that. You change the name of the new satellite that you want to track. All right, I'm using an N2YO, this is the URL, okay, and the API key you get from them, N2YO. And then I've got the position of the satellite, altitude, and down here I've got the formula. Yeah, it's the Haversine formula to calculate my distance, my longitude from their longitude, from the ISS longitude, so you can calculate the distance, otherwise I wouldn't be able to do that. So there it is, distance, now it's 7,700 kilometers. Altitude is still the same, it's always flying above the Earth, and distance 7,800. And sometime it passed over close to about 200 kilometers from me. And in the previous project with the OLED screen, I put an LED, so when you get the distance, get close, the LED goes on when it flies over you. But you can do that yourself. You can look at my other video, and if you look now, 24.9 and 103, and there it is. It's exactly that it is, 24 and 103. So yeah, okay, I think we've cover everything. And yeah, that works beautifully. And now you will have some problem, like in this case, if you look at that, the API sometime goes blank, and the timestamp goes back to 1970. It's working now, but as it works, I think it's. I'm not sure if the satellite it's got some moment where the information is not coming through, and I think it's got to do with the API. How they receive the information from the satellite, and then the API will collect the data, and I access the data with JSON parse. Will come back to Arduino. Yeah, JSON parse will read it and bring it to my screen okay, I'm not gonna specifically but you can see the other things is we have the RX, the white one, goes to D4, and TX goes to D3. Okay, I can also include a GPS tester in case that you have an issue with that. You can test your GPS, because if you don't test it, will come blank. And remember that most of the GPS don't go on immediately. Sometimes takes an hour before the lights start to flash, and when the light flashes, it means that it is receiving information. Okay, guys. And what else I've got? This works all in 5 volt. I made a railing here for the GPS. My GPS, it's 5 volt, and the LCD, it's pin 1 and pin 2. Pin 1 is a ACL, pin 2 it's SDA, and this one is I2C, and use the crystal library. Okay, guys, I think I covered everything, and yeah, please give me a thumbs up if you like it. Have a good day. Bye.